Okay, so we are simplifying rational expressions today. Before we start, what does rational even mean? What's a rational number?
Fraction.
Yes, any number that can be written as a fraction where numerator and denominator are integers. So you already know how to do this. If I give you 6/8, for example, don't you just reduce by a common factor? Yeah, what is 6/8 reduced to be? 3/4, right? So I'm basically doing the same thing, just with algebraic expressions. Okay? So for example, if I had 2x plus 10 over 4x minus 12. Here's what you can't do. You can't just come in here and start reducing. Oh, look, 2 over 4 reduces to be a half. 10 over 12, that reduces to be 5/6. You cannot do that. Why? Because these are binomials. If you just cancel, actually, let me do you don't have to write this down, but if I just do a side example, if you did something like 5x plus 1 over 5, if you just cancel out those 5s, do you think that 5x plus 1 over 5 is the same thing as just x plus 1? No, it's not. You can't just cancel out a part of a binomial. You have to factor out something from a binomial. So, if I look at the top here, couldn't I factor out a 2? Right? If you take a look at that top expression, I can factor out a 2. So let's do that. I'll take out a 2 and I'd have x plus 5 left. Does everybody agree? Yeah? So, I'm done with this. I just pulled out that 2. On the bottom, can I take out a 4? Right? So let's take out a 4, and I'd be left with x minus 3. So now my fraction is really 2 times x plus 5 over 4 times x minus 3. So now what I'm allowed to do, since these numbers are loose, they're not tied into a binomial anymore, I can reduce the 2 and the 4 with each other now. So that just becomes 1/2, right? So 2 goes into 2 once, 2 goes into 4 twice. And that's the best I can do. So that's basically it. I just write my answer nice and neatly. So in my numerator, I still have x plus 5, and in my denominator, I have 2 times x minus 3. That's my answer. That's it. I'm done.
So what's in between the 2 and the x? No, on the final answer.
Oh. That's it. So there's really only 2 steps. So to simplify rational expressions, step 1, you're going to factor anything that can be factored. Factor fully each numerator and denominator. Once you factor, then you're going to reduce whatever possible. And then we can even say step 3, write answer neatly. That's it. If students are going to make a mistake in this section, it's because they don't do these steps in this order. They try and reduce first. You can't. You have to factor first, then reduce if there's anything to reduce. So let's try another one. Let's try 2x plus 6 over 5x plus 15. You would be 100% wrong if you came in and reduced the 6 and the 15. You can't do that. They're part of binomials.
So wait, what do we do?
So, step 1, factor fully. So, just look at the numerator. Don't even look at the denominator. Is there anything that you can factor out of 2x plus 6?
2.
Yeah, take out a 2. Then you look at the bottom. Is there anything you can factor out? A 5. In the last example, these two numbers reduce with each other. This time they don't. But, do you see anything else, Christina? Yes, if the binomials match each other exactly, the entire binomial matches the entire binomial, you can cancel those with each other. I have an x plus 3 that will cancel with an x plus 3. So my answer is just 2/5. Yeah.
What if it was negative? Would it just be negative? If it was like negative x plus 3 at the top.
Negative x plus 3? Then it wouldn't match this one. You couldn't cancel it. There is, I'm actually glad that you mentioned that, because there is one little sneaky trick that you can do. Okay, try another. Let's try, let's see, what could I do? 2x plus 7 over negative 4x minus 14.
Okay, so what if you can't factor it?
Okay, so the top, there's nothing to factor out of that one. So you just leave it. On the bottom, is there anything to factor out of that one?
Yeah.
What? 2. Okay, so if you take out a 2, you're going to be left with negative 2x minus 7, correct? Right?
Or could you take out a negative?
Uh-huh. So, take a look at where we're at. If I take out a 2, I'm left with this. These two binomials are close to matching, but right now they don't match. So that's one thing I could do. I could have taken out a negative 2 instead. So if I take out, I'll rewrite it. If I take out a negative 2, that would have gotten me a 2x plus 7. And now, what happens? You can cancel the entire 2x plus 7 with the entire 2x plus 7. So what is my final answer? Correct. It is not negative 2. Isn't negative 2 in the denominator? So it's 1 over negative 2, right? There's still a 1 there. When you cancel them out, it's just reducing it down to 1 over 1. So a lot of times we don't write it, but there is a 1 there. Yeah.
What if everything is completely canceled out? Would it be 1 over 1?
Yes, or just 1, right? Like, isn't 7 over 7 just 1? Right? So wouldn't x plus 7 over x plus 7 just be 1? Yeah. So if everything cancels, just 1. If everything in your numerator cancels, you have to remember that there's still a 1 there. If everything in the denominator cancels, it's not such a big deal, because 2 over 1 is the same thing as just 2, for example, right? What you can't do, however, is do something like this. Say I had, well, let's try this. Say you had 3x minus 15 over 6x plus 30. Okay, so you had that. So first, just look at the numerator, take out whatever you can. What can you take out of the top? What can I take out of the top? Anything? What? 3. Bottom. What can I take out? 6. Now what can I do? I can reduce 3 over 6. right? 3 goes into 3 once, 3 goes into 6 twice. Can I cancel x minus 5 and x plus 5? No, they are not the same. Well, could I have taken out like a negative 2 down here and turned that into a minus? No, because if you took out a negative 2 here, it would make that a negative x minus 5. It would change the sign of both things there. And that wouldn't help me any, right? Because I need a positive x minus 5. I already have a positive x. So if I took out a negative, it would change both signs. It wouldn't get me anywhere. So the only thing I can do is what I already did, reduce the 1/2. You cannot cancel the x plus 5 and the x minus 5. They're not the same. So then I just write my answer. In the numerator, I still have x minus 5, and in the denominator, I have 2 times x plus 5. Do you have to distribute the 2 on the bottom? No, you can leave it. Why do more work than you have to? You're already done. Are we ready to take it up a notch here?
Nope.
Well, we're gonna. Ready? Okay, let's try this one. Let's see how much factoring you remember. This is going back a couple chapters here. Do you remember? Yeah.
Wait. If it was like 6x plus 30, and then you factored that, you took the 6 out.
Then you got
Oh, wait,
x
I
plus
remember.
5, right?
I
Yep.
thought it wouldn't be.
What does this top thing factor into?
X plus 3 and x minus 3.
Yes. Guys, do you remember? That's the difference of two perfect squares. Remember how that splits up? So, when you have just two terms, and one is an x squared, and this is a perfect square, remember how that just splits into x plus 3, x minus 3? You just take the square root of each one. One's a plus, one's a minus. Now that you see it, you remember it? This whole chapter really reviews the factoring stuff, so we'll review it together. Then on the bottom, of course, I can just take out a 3, x plus 3. And now what can I do? If anything, the x plus 3's, because the entire binomial matches the entire binomial. So they're gone. Can I do anything else? No. No, you can't cancel these 3's because this one is tied into a binomial. It's stuck in there. So that's my answer, x minus 3 over 3. That's it. I'm done. We didn't only factor binomials. We've been factoring trinomials too, right? Of course we have. Let's try one of those. What if you had, let's do x squared minus 16 over x squared plus 5x plus 4. So again, I would factor just the top, factor just the bottom, and then you go in and see if anything cancels out. By the way, it's possible that nothing cancels out. It doesn't happen often, but it can certainly happen. Like if I asked you to reduce the fraction 3/5, right? It's already reduced. So it can happen. Probably won't happen very often though, while we're doing this chapter anyway. Okay, we got answers? Shall I call on you at random?
Absolutely not.
Maddie, what does the top factor into?
X plus 4 and X minus 4.
You got it. X plus 4, X minus 4. Okay, the bottom is just a trinomial. Go ahead, Jess.
X plus 4 and X plus 5.
Perfect. So now that I have both, I've finished step 1, I factored everything. Now step 2, I look for anything that I can reduce or cancel with each other. I do have X plus 4s. They will cancel with each other. Is there anything else I can do? No, so that's my answer. X minus 4 over X plus 1. That's it. Isn't this kind of nice? If you remember how to factor, it makes this all a lot better. Let's try a more difficult one. Let's say you had 3x squared minus x minus 14. And let's put that all over, how about 2x squared minus 8. Yes, that. So if you're looking at the top, always look for a common factor to take out from the beginning. However, I don't think there is one. So how are you going to factor that top thing? I would use t's if I were you. Sometimes it's helpful to do your work elsewhere. Was everybody able to factor this one correctly? So just to recap, if you're forgetting how to factor when a is not 1, you make your t's, put in all the factors that get you to your number. So 3 is just 1 and 3, 14, 1 times 14 or 2 times 7. Because that's a negative, someone's got to be negative somewhere in here. And I'm trying to find pairs that will get me to a negative 1. So I could have done 3 times 14 and 1 times 1. But those pairs won't get me to a negative 1. I could have done 3 times 1 and 1 times 14. But if I add or subtract those, it doesn't get me to a negative 1. So then I tried this pair, and then I realized, oh hey, if I just had a negative 7 and a positive 6, that would add to get me a negative 1. So now that I know it's these two pairs, I jot down that I want a negative 7 and a positive 6. You draw your two sets of parentheses. These two numbers always go in the first spot, x and 3x. And then I needed to get a positive 6, so I need to do 3 times a positive 2. Whatever you're multiplying together, they can't be in the same set of parentheses with each other. So I put the plus 2 there, and the minus 7's got to go there. You can always foil this back together to check and make sure that you have the right combo with the right sign in the right spot. But I think I've got it, but we could check. 3x squared minus 7 plus 6 is a minus x, minus 14. Hooray! So now I have that one. What can you do with this thing? take out a 2, and then I'm left with x squared minus 4. Can I? Exactly. Now it's the difference of two perfect squares. So it splits again. So this becomes 2 times x plus 2 times x minus 2. That's the denominator completely factored. Now step 1 is totally done. You factor everything as much as you can. Great. Step 2, now I get to come in and cancel things out. So it looks like I can do x plus 2's. That's it. So then my answer, 3x minus 7 over 2 times x minus 2. I'm done. Whoops. Sorry. Here's the common question. Well, let me give you an example problem and see if you fall into this trap or not. Let's try this. How about 2x squared plus 20x plus 50, and let's put that over x squared, yeah, under, and then on top I want x plus 7x plus 10. All right, try that one. Okay, we got an answer? Christina, what does the top factor into?
X plus 5 or x plus 2.
Correct. Okay, the denominator, what are you going to do? Take out a 2 to begin with, right? I hope everybody did that. If you didn't, you made your life so much harder than it has to be. There's a common factor of 2. Take it out. And now that I've done that, now what's left here, I can factor again. So what does that factor into? Correct. X plus 5 and x plus 5. Okay, so now step 1 is done. Everybody is factored. So here is a common question. I have x plus 5 here, and then I have 2x plus 5s here. Can you cancel them all with each other? No. It's always a pair, one on top with one on the bottom. So you also can't cancel these two right next to each other. No. One on top, one on the bottom. That's all you get. So, one on top with one on the bottom. I don't think that there's anything else I can do, is there? Because I can't do this 2 with that 2, because that's in a binomial. So I'm done. I've got x plus 2 on top, and then 2 times x plus 5 on the bottom. That's pretty much it. So if you can factor, you're all right with this. There are some exponent things that can get thrown in. So let's just try an exponent problem and see if we remember how to do that stuff. Let's try, Trying to pick one that's not so bad to start off with. All right, that one's not so bad. What if I had a squared b minus 7a squared all over a to the 5th? So your rules are still the same. Step 1 is still to factor. So if I look at that numerator all by itself,
How do you factor that?
good question. Is there anything I can take out of that?
A squared.
Yes, let's take out a squared. If I take out a squared, what's left?
B minus 7.
That's it, b minus 7. So there's the top thing factored. Now, I look at the bottom. The bottom is just a to the 5th. There's nothing to factor there. But is there anything I can reduce with each other? Yes. Can I reduce the a's? A to the 2nd over a to the 5th. You have 2 of them on top, 5 of them on the bottom. So when you reduce them with each other, you'll be left with a to the 3rd on the bottom. Do you remember? Okay. So you're gone, you now become a to the 3rd. And that's my answer. B minus 7 over a to the 3rd. Maybe we'll try one more like this. Let's do x to the 9th over x to the 5th y minus x to the 4th z. Yeah, try that one. Okay, nothing to do on top. On the bottom, what can I take out? X to the 4th. And that would leave me with xy minus z. Correct. Now, I see if there's anything I can cancel or reduce. Is there? Right. If I have 9 x's on the top and 4 on the bottom, when I cancel them with each other, I'll be left with x to the 5th up top. And then just the xy minus z on the bottom. I'm done. See, that's not so bad, is it?
Don't cancel out the x's.
Right. This one is now tied into a binomial, so I can't just do just the x with that one. If I could factor out another x, then I could, but I can't, so that's the best I can do. All right, you guys ready to try some? Well, yes, you can.